Hello everyone, my name is Kenya Isller. Today I will be presenting how GeoGebra Classroom can be used to support instructions in the Grade 8 Functions domain. The Grade 8 Functions domain is one of the most important topics students encounter in middle school mathematics because it establishes the foundations for Algebra 1 and future mathematics courses. Throughout this domain, students learn to identify functions, compare multiple relationships, interpret rates of change, and explain mathematical relationships. Technology has become an important instructional tool because it provides students with opportunities to actively explore mathematical concepts rather than simply completing procedural practice. GeoGebra Classroom is one example of the technology that encourages students to investigate functions through interactive activities while giving teachers immediate insight into student understanding. Throughout this presentation, I'll explain why GeoGebra Classroom is an effective instructional resource for the Grade 8 function domain. GeoGebra Classroom is an interactive instructional platform that supports conceptual understanding throughout the Grade 8 functions domain. The lesson provides opportunity for students to compare functions represented by tables, graphs, equations, and verbal descriptions within a single learning experience. Rather than viewing each representation as a separate skill, students develop an understanding that each representation communicates the same mathematical relationship. According to Miles and Williams, students should move flexibly among multiple representations instead of learning each representation independently. GeoGebra Classroom supports this instructional goal by allowing students to investigate each representation while receiving immediate feedback throughout the lesson. The lesson also promotes mathematical reasoning. Students make observations, compare mathematical relationships, justify their thinking, and revise their responses as they work through each activity. Instead of focusing on memorizing procedures, students are encouraged to explain why a relationship is a function, identify important patterns, and connect their observations across different representations. GeoGebra Classroom also provides important instructional benefits for teachers. Students' responses can be monitored in real time, allowing teachers to identify misconceptions, facilitate classroom discussions, and adjust instructions based on students' understanding. These features support formative assessment throughout the lesson while encouraging meaningful mathematical discourse among students. The GeoGebra lesson focused on several important learning goals within the Grade 8 function domain. One of the primary goals is helping students determine whether a relationship represents a function. Student example examine different representations and determine whether each input is paired with exactly one output. This understanding serves as the foundation for the remaining concepts within the functions domain. Students also compare functions represented by tables, graphs, equations, and verbal descriptions. Miles and Williams emphasized that students should recognize these representations as different ways of communicating the same mathematical relationship rather than viewing them as isolated skills. As students compare representations, they develop a deeper understanding of how functions behave across different mathematical models. And another important learning goal is distinguishing between linear and nonlinear function. Students identify patterns within tables and graphs while interpreting rates of change. They recognize that linear functions have a constant rate of change while nonlinear functions do not. Understanding this distinction prepares students for future work involving slope, linear equations, and algebra 1. Throughout the lesson, students interpret rates of change, recognize mathematical patterns, and explain relationships using evidence from multiple representations. GeoGebra Classroom provides immediate feedback that allows students to revise their thinking as they progress through each activity. These learning experiences encourage conceptual understanding while helping students develop confidence in working with function. The GeoGebra lesson selected for this presentation is titled Tables, Equations, and Graphs of Functions. The lesson begins with a notice and wonder activity that encourages students to carefully examine a graph before solving any mathematical problems. Instead of immediately introducing procedures or formulas, students make observations, identify patterns, and ask questions about what they see. This instructional strategy encourages curiosity while providing teachers with valuable information about students' prior knowledge. As the lesson progresses, students compare functions represented by tables, graphs, equations, and real world situation. Each activity requires students to explain relationships, justify their reasoning, and recognize connections among multiple representation. Rather than memorizing steps, students investigate mathematical relationships and develop conceptual understanding through exploration and discussion. The first activity in the lesson is a notice and wonder. This instructional strategy encourages students to examine a graph before attempting to solve any mathematical problems. Rather than beginning with a question that has one correct answer, students are invited to make observations about the graph and ask questions about the mathematical relationship it represents. Students often notice different characteristics of the graph. Some students may recognize whether the graph is increasing or decreasing, while others may focus on where the graph begins or identify patterns and how the relationship changes over time. Students are also encouraged to ask questions about what the graph represents and how the quantities might be related. Because there is no single correct observation, multiple students are able to contribute meaningful ideas during the discussion. This activity also serves as an effective formative assessment. Responses help teachers identify misconceptions, determine what students already understand, and adjust instruction before introducing new concepts. By beginning the lesson with observations and discussion, students develop a stronger conceptual foundation for the activities that follow, where they would compare functions, interpret mathematical relationships, and justify their reasoning using multiple representation. The next activity asks students to compare functions represented by graphs and equations. Rather than simply identifying a correct answer, students analyze each representation and determine which equation matches a particular graph. This requires students to examine the characteristics of each function and explain how they know the representation describes the same mathematical relationship. Students compare important characteristics such as the rate of change, the direction of the graph, and the initial value. Instead of focusing on individual points, students examine the overall behavior of each function. This encourages them to think about how the graph changes and how those changes are reflected within the equation. As students compare multiple representations, they begin recognizing patterns that help them identify similar mathematical relationships. According to Miles and Williams, students should regularly move among tables, graphs, equations, and verbal description because each representation provides different information about the same function. This activity reinforces that idea by requiring students to connect graphical and algebraic representations rather than treating them as separate concepts. Developing these connections helps students build a stronger conceptual understanding of functions. This activity also encourages students to justify their reasoning. Students explain why they selected a particular equation rather than simply identifying the correct match. These explanations provide teachers with valuable insight into the student thinking and create opportunities for meaningful mathematical discussion. Another strength of this activity is that it naturally reveals misconceptions. Some students may focus only on where the graph begins while ignoring the rate of change. Others may compare individual points rather than examining the overall relationship represented by the graph. These misconceptions become visible through students' responses, allowing teachers to address them before students continue throughout the lesson. After students compare functions represented in different ways, the lesson transitions into guided practice where students apply what they have learned. This portion of the lesson requires students to interpret information presented in graphs and tables, estimate values, and determine whether a relationship represents a function, and explain their mathematical reasoning using evidence from multiple representation. Unlike traditional practice, students are not simply repeating procedures. Each activity requires students to analyze information, make mathematical decisions, and justify their conclusions. Student must connect graphs to tables and explain how different representation communicate the same function. These tasks encourage conceptual understanding by requiring students to think about the mathematics rather than memorizing a process. This portion of the lesson also provides additional opportunities for formative assessment. The teacher can monitor student responses, identify patterns in student thinking, and determine whether additional instruction is needed before introducing new concepts. Because students explain their reasoning throughout the lesson, teachers gain a clear understanding of how students are interpreting fun- functions and connecting multiple representation. Overall, this guided practice reinforces the major learning goals of the grade 8 function domain. Students continue comparing functions, interpreting rates of change, recognizing mathematical patterns, and communicating their responses. One of the greatest strengths of the GeoGebra Classroom is the support it provides for teachers during instructions. Unlike traditional assignments, where teachers often wait until the students finish their work to identify misconception, GeoGebra Classroom allows teachers to monitor students' responses as they occur. This provides immediate information about the student understanding and help teachers make instructional decisions throughout the lesson. Real time monitoring also strengthens formative assessment. Teachers can quickly identify students who may need additional support while recognizing patterns that appear across the classroom. If several students demonstrate the same misconception, instructions can be adjusted immediately before students continue to the next activity. This approach allows misconceptions to be addressed during learning rather than after students have completed the lesson. GeoGebra Classroom also encourages mathematical discourse. Student responses can be used to begin classroom discussions about different solution strategies, common errors, and mathematical reasoning. Rather than focusing on only on correct answers, students can ask teachers can ask students to explain how they reach their conclusions and compare different approaches to solving the same problem. These discussions help students develop confidence while strengthening conceptual understanding. Overall, GeoGebra Classroom supports effective mathematics instruction by combining technology with strong teaching practices. It promotes formative assessments, encourages student participation, support mathematic discourse, and provide teacher with valuable information that can be used to improve student learning throughout the lesson. The GeoGebra lesson strongly supports several mathematical practice standards because students are actively engaging in reasoning, communication, and problem solving throughout the lesson. Rather than teaching the mathematical practice standards separately, the lesson naturally incorporates them into each lesson as the student investigate functions through multiple representation. The first mathematical practice demonstrated is MP1. The practice begins with the notice and wonder activity, where students examine a graph before attempting to solve a problem. The lesson also supports MP2, reason abstractively and quantitatively. Students interpret the rates of change, compare functions, and explain mathematical relationships using tables, graphs, equations, and real world situations. Students move between numerical information and contextual meaning, helping them understand what mathematical quantities represent rather than simply calculating answers. Another important mathematical practice is MP4. Students recognize that functions can be represented in different ways and learn to connect equation, graphs, tables, and verbal description. These activities encourage students to model mathematical relationships while recognizing that each representation communicates the same function. Finally, the lesson supports MP5. Use appropriate tools strategically. Students use the GeoGebra Classroom to explore functions, test ideas, receive immediate feedback, and revise their thinking throughout the lesson. The technology serve as an instructional tool that supports conceptual understanding rather than replacing mathematical reasoning. By integrating these mathematical practice standards throughout the instruction, the lesson encourages students to think critically while developing a deeper understanding of functions. This GeoGebra lesson is considered cognitively demanding because students are expected to analyze mathematical relationships rather than following a sequence of memorized procedures. Throughout the lesson, students compare functions represented by tables, graphs, equations, and real world situations while explaining the reasoning behind each decision they make. The focus remains on understanding mathematical relationships instead of simply identifying correct answer. One characteristic of a cognitively demanding task is that students must justify their thinking. In this lesson, students explain why they match and graph to an equation, determine whether a relationship represents a function, and describe how multiple representations communicate the same mathematical idea. The lesson also encourages students to analyze relationships before selecting an answer. Students identify patterns, interpret rates of change, and compare multiple representation while considering how each representation relates to the other. Instead of following one procedure repeatedly, students investigate several ideas from several different perspectives. This type of reasoning helps students develop conceptual understanding that extends beyond a single lesson or assignment. The other characteristics of cognitively demanding tasks is that multiple solutions strategies are possible. Students may recognize different patterns, focus on different characteristics, or justify their reasoning in different ways. These opportunities create meaningful classroom discussions while encouraging students to compare mathematical thinking with their classmates. Overall, the lesson supports the grade 8 function domain by promoting reasoning, communication, and conceptual understanding. Students develop stronger connections among graphs, tables, and equations and verbal description while building the mathematical thinking needed for future work working with functions in Algebra 1. In conclusion, GeoGebra Classroom provides an effective way to teach the grade 8 function domain by combining technology with meaningful mathematics instruction. The lesson demonstrates how technology can support effective teaching practices. Teachers are able to monitor student responses in real time, identify misconceptions as they occur, and adjust instruction based on students' understanding. These features allow formative assessments to become an ongoing part of instruction while supporting meaningful classroom discussions about mathematical reasoning. Another important strength of the lesson is its connection to the mathematical practice standard. Students make sense of problems, reason quantitatively, model mathematical relationship, and use technology strategies throughout the learning process. These practices are integrated naturally into the lesson rather than being taught separately from the content. Mike and William emphasize that students develop stronger mathematical understanding when they connect multiple representation and explain their reasoning. The GeoGebra lesson reflects these instructional goals by encouraging students to do just that. Overall, GeoGebra Classroom demonstrates how technology can enhance mathematical instruction by providing exploration, reasoning, discussion, and conceptual understanding. These experiences prepare students for Algebra 1 while helping them develop confidence in their ability to analyze and interpret functional relationships. Here's my reference page. I will also be linking the activity with this slide. All right, thank you guys so much for listening to my presentation. I hope that you were able to understand and how GeoGebra Classroom is able to teach the grade 8 functions domain.